and you will find there's great discussion. Not only great discussion, but a great deal of emphasis within the schools and a great attempt to find ways in which to restore the importance of education to our national life. I must say, by the way, that before I talk about the universities, there has been, I think, with regard to the subjects that are important to us, a value turnaround in this society. Now let me give you a couple of statistics on that. A Lou Harris poll at the end of the year reported that an overwhelming majority of Americans believe the recent developments such as computers, biotechnology, and lasers will improve the quality of their own lives. By a margin of 83 to 14%, Americans believe that science and technology in the past have done more good than harm. 86% of the public and 75% of corporate executives said that corporations should increase their contributions to basic research. 82% said that even if it brings no immediate benefits, scientific research is an endeavor worth supporting. Now, I'll tell you, I believe that's a major value turnaround within a relatively short period of time. And it reflects, I think, in many ways, the fact that the people of our society are ahead of their leaders. Going to the universities. For all their problems, they've been undergoing a very positive change. The students seeking to enter engineering are present in great abundance and with outstanding quality. We tend today, frankly, to worry as much about the very good students unable to enter engineering as we do about the declining quality of the education before and during the university experience. My belief is that in our concerns about engineering universities, we certainly should help the very best, but not worry too much about them. I say that because those universities have a growing certainty of their own worth and how to go about demonstrating it, and as a consequence will get support from government, public, and industry in large enough measure to continue very best. Some of my friends from Berkeley don't like that kind of attitude, but I think Berkeley will survive as one of the very best. Student demand, public support, a growing recognition of science and engineering and their place in it, a will to succeed, and the desire to support the best are all in the favor of our very best universities. There is a different problem when we consider the colleges and universities which fall below the very best definition. Here, many of these elements of success are absent, and special efforts will be required to keep engineering from developing into a two-tier system, with the lower tier constantly getting less and less capable. I think it's particularly important, probably the most important problem in our engineering education system as a system. The capability of the students today is as good or better than it ever was. They probably had inferior lab equipment. They probably could have been educated far better, but they are very good. Everywhere, the universities are taking initiatives on their own, which are resulting in an increasing number of joint efforts with industry. I regard this as an effort to succeed with a tangible good to sell, and not as a perversion of the university function. I've seen too many good proposals from too many good groups which represent first-class science and engineering to feel any other way. And we are seeing education more and more discussed as a lifelong challenge. You know, it may seem strange that in our profession it could be regarded as any other way when we're so busy every day outmoding the technology which we introduced the day before. But it's a slow concept coming. I think we're going to have to change the idea that education is for the young and replace it with the idea that learning is for those who would remain young. You know, there was an interesting column in the New York Times the day before yesterday in the science section. And the column made the point that people are discovering more and more that the brain can develop for the whole of a person's life. There are ways to stop its development. One of the ways to stop its development is to conclude that it can't develop anymore and is in fact subject to steady decline. Once that's accepted as a truth, it's a self-fulfilling prophecy and the decline is on the way. But their studies have shown, scientific studies have shown, that in fact the brain can continue to develop all a person's life. That's very important for engineering. It's very important when we have a shortage of engineering talent, because it tells you, first of all, that you ought to believe that, and then you ought to act as though you believe it, and you ought to make the older engineers a heck of a lot more productive because of it. The desire of government to provide a climate favorable to growth and innovation really needs no amplification here. And in fact, it needs such little amplification that I'm going to skip that section of my text because it's been said about 6 different times that I've heard in the last 2 days. Perhaps there has not been enough discussion of the role of state government in making the climate favorable and in fact encouraging innovation and business in the area. But there will be a talk, I can assure you, this afternoon on just that role in Massachusetts. An outstanding paper, in fact one of the best papers I've read in years, and so you will hear all about how local industry and local government can get together to change the climate profoundly. Well, and what about industry? What's positive about industry? Well, I would say one of the most positive signs about industry for acceptance of innovation is that industry has accepted the fact that we are really in a tough competitive struggle. Not only are we in a tough competitive struggle, but we're in a tough competitive struggle where the winners are going to be those who can innovate, including innovation, which produces the very best in quality, function, and cost. For many of our companies, that competition means Japan. But for many of our companies, it means something else. If you take the software suppliers who supply software to the personal computer industry, their competition is not Japan. But they really don't need any more competition, at least as perceived by them. And it's a very, very competitive business. Wherever it comes from, competition, appears to be present in more abundance than ever. The recognition that this is so is to me a very positive factor for our own industrial supportive efforts to achieve top quality, function, and cost, all of which are addressed by factors of innovation. I need only mention that the R&D budget of industry this year is going up about 11%, that in fact it went up through the recession, despite the fact that profits were under attack. To illustrate the fact that I believe industry, or a large part of industry, has gotten the message that you have to make R&D investments in what's a very tough competitive world. There are other signs that innovation is alive and well in industry. I come from Silicon Valley, which Congressman Shaw talked about this morning. Now, for years I've maintained that it shouldn't be called Silicon Valley. It should probably be called Storage Valley. It should be called Storage Valley because of the RAMs, perhaps, but more importantly because of the disk files and the floppies, which are produced in enormous abundance in California. It might surprise you to know that the commercial value of storage products, not counting RAMs, coming out of Silicon Valley, is about the same as the commercial value, as money paid to companies, of semiconductors. So we have fun with that one. The New York Times reports in Silicon Valley that there are about 200 new companies formed per year. Within the last several years, venture capital in that valley has gone from about $1 billion to $8 billion. There are more people with new ideas trying to put together companies to do new things than you can possibly keep track of. And I regard that as a very good thing for the economy. A lot of them are going to fail, and quite a number of them are going to succeed, and the economy is going to be better off for it. The Business Week reports that they couldn't find about 1 million people when they looked at the roles of employment. Subsequently, they found about 400,000 of them who are in the ranks of self-employed. And there are more and more people who are becoming self-employed. In Silicon Valley, it's as consultants, but in lots of other places, they're using the technology today to open up office services companies, clerical service companies, video recording type companies, and so forth. A very positive sign. Productivity. U.S. productivity is on the way up. Partly it's on the way up because it was under enormous pressure through the recession, and companies really had no alternative except to take a very good look at how they could improve their productivity. But partly it's on the way up because of the fact that people have taken a more profound look at what tools and organizations are available today to improve the productivity of their companies. Business Week reports that a lot of experts believe we're going to see a 3% per year increase in productivity throughout the rest of the decade. A very, very positive sign. And that, coupled with the increases in R&D, means the innovation is going to be substantially up. University support out of industry is growing. The last time I checked, NSF said that industry support in universities was running at the tune of about $500 million a year. That's not so much compared to something like the total R&D budget for the nation. But it's quite a bit when you compare it with the NSF budget, and then realize that the industry support goes very heavily to what we term as engineering research. And you realize that it can have a very substantial impact on the campuses, and it can have a very substantial influence on the direction of things that are likely to produce results in industry 5 to 10 years from now. Such efforts as the Center for Integrated Systems at Stanford, originated by Stanford, contributed to by industry, the Microelectronic Lab at Berkeley, the Magnetic Recording Center at La Jolla, and countless other centers and things like polymers and biotechnology across the country illustrate a growing mode of university-industry cooperation on engineering, science, staffing, and education. It was mentioned yesterday that NSF is going to support a couple of hundred young faculty. That sounds like a great program. IBM alone will be supporting 100 faculty this year. So if industry gets its shoulder behind it, these things can be tremendous. One of the most important things that's happened, I think, in industry over the last several years has been the realization that quality is a science, quality is a discipline, quality is an engineering discipline, and that it can be applied throughout the whole of a corporation. John Young of Hewlett-Packard gives a number of speeches and works very hard within Hewlett-Packard because he became convinced that 25% of the manufacturing cost was being wasted in Hewlett-Packard because of lack of quality. And Hewlett-Packard is a high-quality company. It's not at all untypical to have 20 or 25% of the manufacturing effort in our industries devoted to rework and all the other factors of poor quality, not having it done right the first time. That's a lot of money, and that's a lot of profitability, and that's a lot of opportunity for doing it better. Then think about the fact that manufacturing isn't the only place where you can have lousy quality. If the salesman turns in the wrong order, if the engineer designs the wrong product, If it takes 3 passes for LSI design rather than 2 passes, all of those are wastes, and they're all subjects of poor quality, and they're all subjects that can be defects which can be removed with proper attention to quality across the board. You think about the fact that 55% of the people in the United States are employed in white-collar industry. They get 70% of the salary and benefits. And then you think about what you and I could do if we paid a little attention to how their work is performed and apply new tools to them. And there's an enormous potential for both quality and productivity in the society. And many people are thinking about how to make that happen. Finally, when we talk about innovation, we're talking about people. People innovate. Companies can provide the environment, but people do or do not innovate. Those companies which are able to get the very best out of people do it by developing those people, by challenging those people, by encouraging those people, and by growing those people in wisdom and achievement. Now, I'm very optimistic, and because I'm optimistic, I think that the real key is that leaders have to lead. Now, that's very easy to say, but when the climate is right, and real leaders make the climate, it is nevertheless an opportunity and a responsibility. If we've got strengths, then let's build on them. If we've got weaknesses, let's fix them. If we've got too few engineers, of course, let's improve the supply, as many people are doing, many companies and the government and the universities. But let's also improve the productivity of the present engineers. If you can get 5% or 10% more out of the base of engineers now, you've got a whole class of engineers. More than that. And there is not one person in this room, I believe, who would argue that you could improve the productivity of the engineering community by 5% if you thought hard about it. Keyworth said yesterday that it's a critical problem to prepare the next generation. And I say it's an equally critical problem to get the best out of the present generation. If the balance of industry or community focus is negative, then let's take a leaf from Ray Stata, who's going to talk to you this afternoon about Massachusetts, and change it, as Massachusetts did. If young engineering faculty is not coming to the university, then change the equation, as NSF, Hewlett-Packard, the American Electronics Association, and IBM are doing. If the university efforts are inadequate in CAD/CAM, computer-aided design and computer-aided manufacturing, or engineering for manufacturing, change it, the way IBM and other companies are doing. If engineering is not getting adequate national support, let's change it, as Keyworth, IEEE, ASEE, National Society of Professional Engineers, and many companies are doing. If, as Cy Ramos says, no company or country will be able to lead in everything, then how do you decide what's most essential, and how do you assure that you know enough to know where to get the rest? Good companies are doing that today. If productivity, quality, new technology are required, then let's get to it, as GM, Hewlett-Packard, and others are doing. We have a wealth of opportunity for new growth in communications, information processing, in biology, in agriculture, and in the application of these and other science and technology to our existing ailing industries. Well, I assure you I'm at my 20 minutes. But it really means deciding that you're going to make it happen. It means deciding that you're going to build your organization. It means deciding that you're going to build your contacts with the leadership elements of the future, which means the universities. It means building people in an industry, university, accomplishing, learning society. Thank you.
Thank you very much, Dr. Anderson. I have to tell you that my job is an extraordinarily frustrating one. With speakers like we are having, there are 20 or 30 questions just waiting to come from the audience, and I cannot take any of them because it would not be fair to the next speakers. There will be a press conference. Our 3 speakers will be in the conference theater at 10:30 this morning for a press conference for any of the press or anyone who would like to go. The next session begins at 11 o'clock. And so there may be some time. I wish we did have time, and I just apologize that I cannot now take questions. Our next speaker, Mr. F. Grant Saviors, is Vice President of Storage Systems Engineering and Manufacturing at the Digital Equipment Corporation. He's a graduate of Case Institute of Technology, where he received his BS and MS in engineering. He has held a number of jobs in DEC, including Engineering Manager of Disk Development. He managed the Storage Systems Development Group. Currently, he's responsible for engineering and manufacturing operations in a variety of locations around the country and indeed around the world. He has corporate responsibility for Digital's Japan Research and Development Center in Tokyo. He has been DEC's representative on the MCC Board of Directors. It's a pleasure for me to introduce to you Mr. Saviors, who will talk about realities of the international high-tech marketplace. Okay.
Thank you. Of course, one of the questions I'm sure to get is what's going on with the Japanese 5th generation program. This being an election year, it is conceivable that sometime down the road, our politicians will be using artificial intelligence systems to help them with their election campaigns. I'm reminded of this story. President Mitterrand of France will be sitting down at a terminal a couple of years from now, trying to figure out what's going to be the state of the French economy at the time of his election. The good news here is he's typing on a computer. So the first question he asks of the computer is, what will be the inflation rate? And there's a pause. The computer types back 0.0%. That's very good. So the next question he asks is, what will be the unemployment rate? And the artificial intelligence machine now computes a little bit longer and types back 0.0%. Magnifique. Things are really looking up. One more question. What will be the price of a loaf of bread? This time there's a little longer pause. The computer types back 2 rubles. Well, so much for how artificial intelligence is going to help our future. I'm really glad to be here today and grateful for the opportunity to speak to you. It's amazing to me to see how we have, if you will, a consensus here of ideas. Congressman Zhao this morning expressed many ideas that I will also talk about. But I'd like to talk some about the realities of the international marketplace. Factors which make the economic and planning requirements of that marketplace very different from the historical international markets that U.S. industry has participated in. And we've got to adjust our way of thinking to these new requirements, and we're really facing these issues in a major way for the first time. So whether we're companies weighing R&D decisions or legislators grappling with the complexities of international trade or just individuals interested in the competitive race, we have some mindsets to change and some strengths to build upon. First, let's look at some of these realities using the computer systems industry as an example. The U.S. computer systems company that expects to be able to compete effectively in international markets is faced with 2 fundamental issues: the increasing cost of development and an unprecedented pace of technological advancement. This pace reduces the product life cycle significantly, and the margin for error is frequently less than 1 year. In computer systems, for example, this poor decision-making can delay programs for several months, but these several months can have a dramatic impact and irrevocably lock a producer or a nation out of the marketplace. Today, the U.S. Computer systems manufacturer with international operations is investing from 8 to 11% of its operating revenues in R&D. This figure is in contrast to the 2 to 3% that is typical of U.S. industry. The rate of technological change that keeps leveraging that level of investment is manifested in the industry as exponential price performance improvements to the customer. Price performance has improved about every 2 years by about a factor of 2 for the last 2 decades. And this has been the fundamental vitality of the computer industry. In addition to its high investment in R&D, the computer systems manufacturer invests another 10% of operating revenues in capital equipment and facilities. That investment is also higher than traditionally required in other industries. For example, as recently as 1965, it took $1 million to tool a state-of-the-art semiconductor facility. Digital recently completed an upgrade of its current facility, and that investment exceeded $50 million. Bricks and mortar are a very small part of that investment. Specialized test equipment and sophisticated instrumentation have to be developed. If Smokestack America replaces major production machinery, they typically expect tens of years of life out of that equipment. If we open a plant to produce semiconductors, it may be useful for 2 or 3 generations of product. Nearly complete retooling will be required in 5 to 6 years. As the technology changes, both the product technology and the process technology, you're constantly facing major reinvestments in new facilities that overlap current investments. The engineering process itself is also becoming incredibly capital intensive. I think the shortage of trained personnel and, to reflect on Art Anderson's comments, our drive for increased engineering productivity are driving up the capitalization costs for a new engineer tremendously. I believe it takes on the order of $250,000 for us to properly provide facilities for a new engineering graduate. That's in computers, test equipment, oscilloscopes, and the like. And of course, with that kind of investment on our part, it leverages significantly the cost of the education of that engineer. So we are looking at a combined investment of up to 20% of operating revenues in R&D and capital equipment. In addition to huge investment requirements, the high technology sector is subject to high taxes. Ongoing studies by the Joint Committee on Taxation of the U.S. Congress have shown that effective tax rates of high-tech industries range from 40 to 75% above industry averages. These disproportionately high rates result from substantial investments in short-lived equipment, the very investments we must make in order to continue to compete. The accelerated cost recovery system of the 1981 tax cut was hoped to help revitalize America's aging industrial production facilities. This tax change, however, falls short of recognizing the unique realities of the high-tech industries on which our future depends. In spite of the high levels of investment required and higher effective tax rates, we've been very successful. In our zeal to face reality, let's not lose sight of that success. Typically, 30 to 40% of a computer systems manufacturer's income comes from international markets. And our industry has been profitable in spite of the 82-83 recession. And the growth in number of jobs parallels our success in the international marketplace. And our sector has contributed over $6 billion in the U.S. trade balance in 1983 alone. And we continue to be leaders in international markets in data processing and microprocessors. Our concern is that the international competitive balance may be tipped in favor of foreign competitors, not by any lack of effort on the part of U.S. companies, but by the actions of foreign governments in support of their industries and by our own government's lack of focus on the impact of its policies on American technology. Targeted policies by our trade competitors have increased the competitiveness of their industries, and we are poorly prepared to deal with this. We know now from competitive data that it's not our inalienable right to have technological supremacy. These policies and the adverse consequences in terms of domestic and foreign market share of U.S. high-tech firms must be responded to. Foreign government actions have already limited the ability of U.S. firms to compete in some of their markets and may in fact be able to preclude our entry into some markets entirely. Foreign governments have also utilized a variety of measures to support their national firms at the expense of U.S. competitors. In short, the actions of foreign governments often make markets unavailable to U.S. firms and protect the firms at home from the competitive capabilities of the U.S. firms. But we're not for protectionism. We should not let these issues drive us into a door-slamming exercise. Protectionist legislation simply doesn't work in the high-tech environment where the price-performance ratios and product life cycles are so short. The customer just isn't going to buy your product if he can get something cheaper, better. Protectionism and subsidization of high-tech in other countries, notably in Japan, are of concern to digital and to other U.S. high-tech firms because they force us to compete with government-supported companies on terms set by the foreign governments. As an example of what I'm talking about, let's look at the infamous trade in semiconductors, particularly in random access memories. The SIA released a study that reported that since the late 1970s, Japanese semiconductor firms have received subsidies, low-interest government loans, antitrust immunity, and extensive government R&D assistance. This has clearly lowered the Japanese firms' costs. As a result, the Japanese companies have been able to dramatically increase their production capacity and launch an export drive that has had a serious adverse effect on the U.S. semiconductor industry. In 1981 and 1982, SIA estimates that U.S. firms lost an estimated $144 million on 16K and 64K RAMs. In spite of the fact that memory accounts for some 15% of all equipment revenues of American computer systems manufacturers, a number of U.S. firms have pulled out of the memory market, most notably the 256K market. This is clearly an example of a situation in which foreign government programs have resulted in a disincentive for innovation and investment by U.S. firms. In fact, American systems manufacturers themselves have had to buy large quantities of Japanese semiconductors in order to help bring down their system costs and remain competitive in international markets. The U.S. government has entered into a series of discussions with Japan, which resulted in the establishment in early 1982 of the Japan-U.S. Working Group on High Technology Industries. The activities of this working group are extremely important for U.S.-Japan trade in high-tech products. If enacted, it will reduce bilateral tensions in semiconductor trade. If U.S.-Japan friction can be reduced or resolved amicably,